This slide set is about IPv4 addresses. An IPv4 address always comprises 32 bits and belongs to a network interface. The general concept of IPv4 addresses is that these addresses are worldwide unique, so that they are valid end-to-end. However, this concept does not hold anymore if network address translation is used, which is frequently the case. Network address translation is explained in another video. The typical representation of an IPv4 address is a decimal notation. So each byte is represented as a decimal value and the bytes are separated by dots. The beginning of an IP address shows the network and the remaining bits are used to distinguish between end systems or routers in the network. Network interface is the naming for a piece of hardware that allows a computer to communicate with a network, such as an Ethernet interface or a wireless LAN interface. Host is the name of a device that is part of a network. It can be a personal computer, a smartphone, or a server. When the internet was designed, hosts had only one interface. However, hosts such as notebooks can have several interfaces, but hosts do not route between the interfaces. This means that all traffic originates at or terminates on the host. In contrast, routers relay traffic. A router has several interfaces and forwards an IP packet that it receives on one interface to an appropriate other interface. In the context of the Internet Protocol, the term network has a special meaning. All interfaces that have IP addresses with an identical network part belong to the same network. In the figure we see, for example, the computers 223.1.1.1 and 223.1.1.2. They belong to the same network, which is named as 223.1.1.0/24. The 24 indicates how many bits belong to the network part of the IP address and how many bits are available to distinguish between hosts, or more precisely their interface cards, in the network. Closely related to the indication of the network part length after the slash is the network mask. In the network mask, all bits that belong to the network part are set to 1 and all bits for the host part are zeros. Therefore, for a /24 network, the network mask is 255.255.255.0. The network mask is used to determine whether a destination IP address belongs to the network of the source or not. The test that you see in the middle of the slide compares the network part of source IP address and destination IP address. On this slide we see the impact of the test result. If the test shows that the source and destination hosts are part of the same network, then it is possible to directly provide the IP packet to the destination by the means of the data link layer. A router is not involved in this case. The situation is different if the test shows that the destination host is in another network. In this case, a router is needed because a router connects different networks. Therefore, the source has to send it to the router and the router then takes care to forward it to the destination network. In the figure, the destination network is found on the other network interface of the router. However, this is often not the case, so that several forwards to other routers are required. For the second case, where a router is needed, each host has to know the IP address of a router in the local network. This piece of information is called default router or default gateway. The wording default gateway is no longer appropriate, but you still hear it quite a lot. So it is crucial that it is configured on the host manually or automatically, because otherwise the host can only communicate with hosts in the same network. There are some addresses with a special meaning. The address 0.0.0.0 is either a temporary address that a computer uses if it has not a proper IP address yet. If in a local routing table, it also stands for the default router. The address 127.0.0.1 is called localhost. It is useful for testing purposes because packets which are sent to this address are actually not sent on the medium. They stay inside of the computer. This is useful if you develop a web server-based application on your computer and you want to access it with a browser. Then you can enter this IP address in the browser input line. If all bits of the host part of an IP address are set to 1, then this is the broadcast address for the local network. Furthermore, there are so-called private IP address spaces. For these address spaces, an agreement holds that these addresses are not routed in the internet. Everybody can use these addresses in an own network without coordinating this with others. See the video about network address translation to learn more why these addresses are useful. For the global administration of IP addresses, there is a hierarchical structure. On the top, there is the ICANN, which carries out the IANA function. The global address space is distributed to regional internet registries, which are responsible for different parts of the world. The regional internet registries provide address spaces to national internet registries, and these supply address spaces to internet service providers. An internet service provider has several tasks. It provides IP address spaces to its customers, takes care of routing so that the customers can access the internet, and also administrates records of the domain name system.